Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 32, and this problem asks us for which of these following compounds are aromatic, and for any compound that's not aromatic, state why. Well, in order for a compound to be aromatic, a few things need to be satisfied. Number one, the compound must be cyclic, so all of these are cyclic. Number two, must be planar, which all of these are. Number three, it must be completely conjugated. That means every single carbon in the cyclical structure must be an sp2 carbon. And why an sp2 carbon? Well, sp2 carbons are carbons that are involved with double bonds. So every single carbon here is sp2. So another way of thinking of it is that you have to have alternation of double bond, single bond, double bond, single bond, double bond, single bond. If, for example, you have two carbons that are not adjacent to a double bond such as this carbon would actually be an sp3 carbon. Why? Because it has two hydrogens. So this would be an sp3 carbon. So this would not be fully conjugated. The last thing it needs to have or satisfy is it must satisfy Huckel's rule that the number of pi electrons must equal 4n plus 2 pi electrons. N being any positive integer and 0. So it must have 2, 6, 10, 14, etc. pi electrons. So now with these rules in mind, let's look at A. So A, right off the bat, we see that we are expecting something, a pattern like C. Double bond, no double bond. Double bond, no double bond. Double bond, no double bond. But here we have double bond, no double bond, no double bond, no double bond, no double bond. So clearly we have sp3 carbon, sp3, sp3, sp3. So this structure right off the bat cannot be aromatic because it is not completely conjugated. Therefore, this is not aromatic because it has sp3 hybridized carbons and not all sp2. So right off the bat, we don't have to check Huckel's rule because this is not completely conjugated. So what about for this one? Well, this one we have double bond. Then this one is also an sp2 carbon because it's actually a carbon with only 3 bonds because it's a carbocation, so this is okay. But then here we get a carbon with 4 bonds, so this is an sp3 carbon. So right off the bat, this is not a conjugated system, even though it satisfies Huckel's rule. This is not completely conjugated, so it cannot be aromatic. Now, what about this one? Well, it's a double bond, no double bond, double bond, no double bond, double bond, no double bond. So it's completely conjugated. Every single one of these carbon atoms in this molecule is sp2 hybridized. So now and it's planar and it's cyclical, but now let's see if it satisfies Huckel's rule. So this has 2, 4, 6, 8, 10, 12 pi electrons. If you see here, 12 is not part of these possible values. If I do 4 times 2, that's 8, plus 2, that equals 10. If I do 4 times 3, that's 12, plus 2 equals 14. So this is actually what we call anti-aromatic because it follows the 4n rule. N being any integer, in this case it's 3. So 4 times 3 equals 12. So because this is an anti-aromatic compound, this compound is actually extremely unstable and it's most likely wouldn't exist in nature because of its instability. Aromatic compounds, on the other hand, that follow the 4n plus 2 rule are extremely stable. So now let's look at this structure. Well, this structure, it's cyclical. Every single carbon here is sp2 hybridized. It's fully conjugated. It's planar. So now let's see if it satisfies Huckel's rule. So I have 2, 4, 6, 8, 10, 12 pi electrons. So once again, from just like in C, this is not going to be aromatic. Because it does not satisfy Huckel's 4n plus 2 rule, it satisfies the anti-aromatic rule of 4n. So none of these 4 examples in this problem were actually aromatic.